All right, so let's talk about a double angle formula, the half angle formula, and the product sum formula. All right, so we have a lot more formulas we need to go through. So let's just slowly crunch through them. All right, so the formula for sine. So if I have sine of 2x, I can rewrite this as 2 sine of x cosine of x, right? And this becomes super useful in solving problems because you get back to your boring sine and cosine x, and then you guys know how to manipulate that. Here, for cosine of 2x, you have that's equal to cosine squared x minus sine squared x. And then there's actual other forms of this one. That's kind of, I did not write them down here for whatever crazy reason. So let me open up the book. Yeah, so there's other forms of this one. This is going to also equal, let me write it down, 1 minus 2 of sine of x. And the reason that I didn't put them here, though I probably should have now I think about it, is because cosine of x, cosine squared of x is equal to 1 minus sine of x from our little Pythagorean theorem. Remember how we can move that over? We did this a lot yesterday. Well, I could just plug that into here, so I'll get 1 minus the sine of x minus sine squared x. So I get minus sine, oops, forgot my squared on it, minus 2 sine squared x, right? I can do the exact same thing here with sine. I can write this as 1 minus cosine squared x, so that'd be, and then if I did it that way, I'd get 2 cosine squared x, because the minus would cancel with this minus if I distribute it, minus 1. And there'll be different times you're going to want this and this. You only need to know this one because using Pythagorean theorem you can produce the other two, but it's not a bad idea to have them written down. All right, so we got there. And so let's go ahead and so just as kind of a refresher for what we did last time, let's prove the double angle formula for cosine. So here, cosine of 2x is equal to cosine of x plus x. This is something we knew how to deal with before, right? If I have the, because if I had that before, I could rewrite this as cosine of x times cosine of x minus, in this case, sine of x, the first one, sine of the second one, which is in this case x. Well, this is just cosine squared x minus sine squared x. And so that's just, so that's where this formula kind of came about. And if we did the same thing with, we could do the same thing for sine of 2x. So, um, so let's go back to these little fun games we play. These, given cosine of 2x, what's if cosine of x is this, let's find cosine of 2x and sine of 2x. And so let's kind of wander through this. And so if cosine of x equals 2/3, I can draw a triangle for that if it's in quadrant 2. So if it's in quadrant 2, what do I know? I know the triangle is going to look like this. And the reason I draw the triangles this way is because I pretend like I'm in my coordinate plane. Because if I'm in quadrant 2, my adjacent side would be -2, my opposite side would be +3. It's a little bit more clear. Write on the right thing so I can do this. This will be my x. Well, if this is 3, this is -2. What is this? Well, remember what it was. It's the square root of the. Oops, I put this in the wrong spot, didn't I? This is -2. The hypotenuse is 3, so it goes here. And I want to figure out what this is. And so how do we do this? We take the square root of our hypotenuse squared minus our other side squared, so -2 squared, which gives us, I'm trying to show this in my head, gives us 9 minus 4, so it'll be the square root of 5. Right, so this is the square root of 5. Right, now that I know that, so what's cosine of 2x? Well, cosine of 2x is equal to cosine squared x. And in fact, I'm actually, because I can use, let me go back. So cosine 2x. Here, I have the option of using this one, but I'm going to use this one. And the reason being is I have this as a nice clean number. So let's use that one. So I'm going to do 2 cosine squared x minus 1. Well, that's equal to 2 times minus 2 over 3 squared minus 1, which equals to 8 equals to 4 ninths. Let me do this slower. Equals to 4 ninths times 2, which will give me 8 ninths, minus 1 will give me a negative 1 ninth. So that is cosine of 2x. For sine of 2x, we're going to use this formula, which gives us 2 times cosine of x, sine of x. Here, I'll write this down here, 2 cosine of x is 2 times the square root of 3. Sine of x here is square root 5 over 3. And so if I crunch this all together, I'm going to get minus 4 square root 5 over 9. Okay. And so that's how we find these two. Everyone okay with that? I forgot how confusing double angles were for me. Yeah, here if we have a double angle, you just kind of crunch so we don't work through it. All right, let's go to the next one. All right, so let's pretend we have this. We want to write, and so in order to solve some of these more advanced identities, we're going to have to be doing stuff that we need to break these down in terms of just sine or cosine or sine. So let's do this. So this is the cosine of 2x plus x, right? So that's a good way of breaking it up. Then we're going to run it through the formula. So here we get cosine of 2x cosine of x. So there was a really good reason I showed you how to break it up from, how to prove it from the single double x, because here we're going to use that theory here, minus sine of 2x sine of x. And this is just from our addition formula. So cosine, cosine, minus sine, sine. But I know what this is, and I know what this is, so I don't actually have to recalculate it. So that is 2 cosine squared x minus 1 times cosine of x minus 2 sine of x cosine of x sine of x. And then if I write this, and so let's go ahead and distribute the cosine. We're going to, and then combine the sine. So this will give me 2 cosine cubed x minus cosine of x, then minus 2 sine squared x cosine x. All right, and I want to write this only in terms of cosine. So here I have cosine, cosine, cosine. Well, can I write this in terms of cosine? Yeah, well, here we're just going to write 2 cosine cubed x minus cosine x minus 2. Here I can rewrite this as 1 minus cosine squared x. Remember that, we've done this lots of times. This comes from the Pythagorean theorem. Cosine of x. Then I just distribute across. I'll get 2 cosine cubed x minus cosine x minus 2 cosine x, remember the 2 and the cosine have to come in, minus 2 cosine, so minus the minus becomes plus, cosine squared x, or cubed x, gotta bring in the 2, cosine as well. And if I put that all together, I get 4 cosine cubed x minus 3 cosine x. And so the point of all this is to get you very used to doing math manipulation. And so you just kind of work through it real slowly. The reason I saved this set of notes to be done singly, even though we've done two things of notes every day. I think this is the only day that we do a single set of notes. This is a lot of material in one section, and so I want you to. I don't want to. Yes, I have to. Yes, in order to do this class properly, we take a year's worth of material and cram it into 5 weeks. And so we're going at kind of a breakneck pace for almost everybody. You, me, everybody. It's a real fast pace. And I get that. But this set of notes, I'm like, no, I don't care how busy we are. We have to do it slowly, carefully, and that way we don't get anyone lost. It comes from the form. I don't understand where the sign came from. Oh, this right here. So sine of 2x is from the previous page, right here. So that's where I got that one from. Yeah, if you ever have any questions where I'm pulling these from, please stop me. And like, where did this one come from? This one came from the Pythagorean, or I guess not the Pythagorean. I think they're called the Pythagorean Identities. My brain's all squishy right now. Yeah. So this square is this as equals 1. And then if you just move over, if you move over the cosine, you'll have 1 sine squared equals 1 equals 1. That's where that one comes from. All right, so let's get into kind of what you'll be doing. So let's pretend we had to do this, right? So here we're gonna look at which side seems more awful. Well, this side seems more awful, right? So the right-hand side seems the most. So we'll work on that one and see where we get. And in fact, we're not gonna work on, in fact, we're just gonna work on the top of the right-hand side. We're gonna even ignore the bottom for a second. What is sine of 3x? Well, sine of 3x is equal to sine of 2x plus x, so you can split that up that way. If I had sine of 4x, I can write it as 2x and 2x, and then you can print out something. According to our rules, it would be sine of 2x cosine x plus then cosine x, or cosine of 2x, sorry, cosine 2x, the first one, and then sine of x. Here, we crunch through what that is. Sine of 2x is 2 cosine x sine x, or I guess I wrote it the other way, sine x cosine x. I guess it's fine. Let me write it the way you see it. I know it's technically okay, but let's keep it as simple as possible for you guys. So that's what 2 sine x is. Then we're going to multiply by another cosine x, 2 cosine x in this case. And in this case, I'm going to use the 2 cosine squared again, x minus 1. I'll use the same one we used last time up here. And I'll have sine of x. All right. And so let's go ahead and, am I on the right-hand side? This is the left-hand side. Don't mind your professor's dyslexia. This is on the left. So let's go ahead and distribute that. In fact, let's go ahead and write the whole thing now. Now we can write the whole thing. Let's do the whole left-hand side. So here we'll have 2 sine of x cosine squared x plus, let's go and distribute our sign to cosine squared x, sine of x, put that in, and then minus sine of x. All right, that's all going to be divided by cosine x, sine of x. Okay. Can I put something together? Yeah, I can put these two together, right? So this will be 4 sine of x cosine squared x plus, oops, minus sine of x, right? Because I can put these two together. Let's put sine of x here. And then here I'm going to divide it all, but in this case I'm going to, which is a safe operation to do, is I'm going to split my fraction apart. Because if I took this and I did the operation, since I have the same denominator, I get what's up here, right? So I split my fraction apart. Well, this allows me to do everything I want to do. Here, I can get rid of one of the cosines, and right here, so I'm just left, and then I can get rid of the sine. So I'm just left with 4 cosine x. That's all that's left here. Here, what am I left with? Get rid of the sine, get rid of the sine. 1 over cosine x is equal to secant x. What does that equal? Well, it equals my right-hand side. And I'm done. Okay. So when it comes to the identities, which you have attempted and started, just work on one side and try to make and try your best to simplify it. In this case, I just simplified directly to the side. All right, let's talk about more fun things. Here we're going to have our lowering powers theorem. So here's how we can lower powers. So let's pretend let's pretend for some reason I don't want everything in single powers and I'm okay with the double angles, right? And so if I resolve, if I resolve things, if I took all those double angle formulas and I resolved them to get rid of powers, this is what I would get into. So we're not going to prove how these came about, but you can see. Let me show you one. Let me just show you one because this is really easy. 2 cosine squared x minus 1 is equal to cosine of 2x, right? That's something we did. So if I just move this over and divide by 2, I get cosine squared of is equal to cosine of 2x plus 1 all over 2. And so these are just reworking of the double angle formulas in order to lower powers, because sometimes that's what you want. So let's pretend we have this expression here and we want to write it all as just the first power of sine, first power of cosine. All right, so how are we going to do that? Well, first we're going to plug in both the formulas. So here I'll have 1 minus cosine squared, or 1 minus cosine of 2x over 2 for the sine, and then for the cosine I'll have 1 plus cosine of 2x over 2. All right, here we have a difference of squares, so it'll be 1 squared minus cosine x of 2x squared over 4. Well, unfortunately, that gets us back to a power, so we're going to have to downgrade that. So here the 4 came from 2 times 2 gives us 4. Here if I have 1 plus something, 1 minus something, and I do the FOIL expansion, it's the first thing squared minus the second thing squared. So I'll get rid of this, and so I'm going to say cosine of 2x. So I'll have 1 minus, and then I'm going to plug in what, I'm going to reduce this down to cosine again. So this will be cosine squared. So cosine squared of 2x will be 1 plus cosine of 2x times 2. So it'll be 1 plus the cosine of 4x. Because here, if I already have the 2, I need to put another 2 up in here. Divided by 2, all divided by 4. And then this is fine. You've achieved your goal at this point. It's only expressed in first powers of cosine. If you wanted to clean it up, you could say a fourth minus 1 plus cosine of oops, 4x over, these would come up together and become 8. Make that look clear. So here it's just, you just keep plugging in the formula until you get what you want. Okay, that's the end of this one. All right. Let's do a couple other fun things now that we have these fun formulas. All right, so let's pretend I want to, you get something like this, and I want to write it in an expression of only an x only, and I know x is between 1 and -1. The reason I have to say x is between 1 and -1, if not, this has no solution. Okay, so the goal of everything I'm trying to show you is how to do different steps for different things. I think I skipped a page. Did I skip a page? I think you are dead right. Well, I skipped a page because I never loaded the page. Thank you. Thank you, thank you, thank you. All right, where are we at? Where are my notes? Open up the notes. Load up the page. Page 4. Let's do this. Ah, the half angles. Yay, half angles. All right. All right, so here's the half angle formulas. Oops, that's not what I wanted to do. Go back to my pencil. There we go. So these half angle formulas are formed same way, same bands, but so just pick whatever one. The choice, you'll see these plus minuses here. So which one do you choose? You choose the quadrant where x divided -2 lies, okay? And so you'll have to actually crunch that in your head. And it's like, well, what is that value? Because you're going to plug in full cosines, but it may be plus or minus that depending on where your where your half angle lies. And so if you were at 2 pi over 3, well, that's in the second quadrant, right? But if I took half of that, that's just pi over 3. Well, that's in the first quadrant. And so here, if I was trying to figure out my half, it'd be the positive for these, okay? So it's whatever half of that angle of x. So if x here was 2 pi over 3, the way I figure out what sign it is like this. And we'll do 2 of them. It'll make sense which way to do that, okay? So let's do this. All right, so if I wanted to find the exact value of 22.5, well, degrees, well, that's the sine of 22.5 degrees is just half of the sine of 45 degrees divided by 2. And that allows me to precisely find what the answer is. So we're just going to plug in this formula. So here, we're going to choose plus or minus. Which one do we choose? We choose the positive. Why? Because this is in quadrant 1, okay? And we square root of 1 minus the cosine of 45 degrees all over 2, okay? So here, if I'm choosing my x to be 45, and that way 45 divided by 2 is 22.5. And so here I can precisely find this. Do I know what the cosine of 45 degrees is? Well, yes, I do. It is square root 2 over 2, right? 2 all divided by 2. I simplify that out. I get, you can leave it at this point. I'm okay with that. If I wanted to simplify, it'd be 2 over 2 minus square root 2 over 2 all divided by 2, which would be the same thing as square root of 2 minus square root of 2 over 4, and I can pull out the 4 as a half, and so I get 1/2 the square root of 2 minus the square root of 2. So this is the precise answer. All right, so let's say find tangent of x over 2 if a sine of x is 2/5 in quadrant 2. So let's do this. All right, so I want to find the half angle for tangent given this. So if I'm in quadrant 2, I know my triangle looks like this, right? Here, this will be my x. So here, the opposite will be 2. The hypotenuse will be 5. This will be, this right here in this box will be the square root of 5 squared minus 2 squared, because that's how we find the other side of a triangle. This will be 25 minus 4, so this is equal to the square root of 21, whatever that is. And since this is in quadrant 2, remember this will be negative, so negative 21, square root 21. Could you go back to example 5 real quick? I want to look at it. Sure. Example 5, no. Yes. This one? All right, I see. My brain is full of comma. It's becoming my reality. I feel that. Aren't you glad I'm only doing one section today instead of 2? I'm afraid if I did 2 sections after this, we'd just be like, I'd just be destroying you guys. Where am I at? I need to be on 4. Okay. So here's this triangle. We've done this lots of times now. Hopefully it's starting to get somewhat familiar. So, but what do I want to find now? I don't want to find tangent of the half angle. Well, I have information up here. I can use this, right? And so we're just going to grab the first one, 1 minus cosine of x over sine of x. So we're just pulling the formula from up here. Cosine of x is, in this case, negative square root, so 1 minus negative square root of 21 over 5, right? Adjacent over hypotenuse over, here we already knew what sine of x is, 2 over 5. Yeah, and then technically you can leave it here. In fact, for today's class, let's go ahead and do that. Could you manipulate it, make it look better? Yeah, sure, but don't worry too much about it. No, it's best that I show you the manipulation every time. So this would be 5 over 5 minus square root of 21 over 5 all over 2 over 5. Notice here the over 5's everywhere. And so you can just cancel that out. So you'll have 5, the minus, minus the minus becomes positive. So plus square root of 21 over 2. Because here I can cancel out the 5, 5, and 5. And so if I gave you this as a multiple choice, this would be the multiple choice answer, which is correct. Which I think for these, I'm going to have to kind of do some of them as multiple choice. So the hard part about multiple choice is making good outliers. All right. Has to be negative. Oh, why is this square root 2? Wait, so yeah, so here I'm in quadrant 2. And so so if I'm in quadrant 1, my x and y values are positive, right? If I'm in quadrant 2, my y value is positive, my x value is negative. If I'm in quadrant 3, both my y's and x's will be negative. If I'm in quadrant 4, my y value is negative and my x value is positive. And so when I draw this triangle, even though negative length doesn't make any sense, it is correct for my quadrant. And so that's why I do it that way. It keeps it simpler. All right, now I go back to I did page 4. Now we go back to page 5. All right, let's go back to page 5. All right, so let's crunch through this. All right, so here I'm going to write this in an expression of x only, where this is from that. All right, so let's crunch through this. So let's start with the inverse cosine of x. Trying to think of why I did this problem. We don't know. We'll just crunch through it. So here, cosine of x. So here we'll have x. Hold on, what am I doing here? Hold on. Let's do this correctly. All right, so x is between this. So I'm going to say this gives me some angle phi, right? Do I know what that angle is? No. But let's say it gives me some angle phi. Because then I'm going to say cosine of phi is equal to x, or the inverse cosine of x is equal to phi. And then I'm going to find sine of phi. So that's how we're going to proceed for this. Let's assume that we're in the first quadrant, just for kicks. We don't really know what quadrant we're in. But cosine, the inverse cosine will give you the first or second quadrant, but as long as I know what x is, depending on the sign of x. So here we have phi. Oops, phi. I'll draw it as phi. So here, the first thing we want to do here is just rename the inverse of x as phi. Same thing we did last time, right? So last time we have 2, this time we only have 1. Cosine of phi is equal to x. Here I have an x. Here I have a 1, right? Because this would be the same thing as 1 over x, right? So opposite, or adjacent over hypotenuse. This becomes, according to my theory, x, or, oops, 1 minus x squared. And so here, the sine of phi is equal to, as I've simplified this to, the opposite, square root 1 over x squared all over 1. Which is just, okay, so this one's actually easier. I don't like these type of questions, my brain burns. I'm still curious why I gave this one on the 7 notes. No clue. Maybe just to remind you how to do these. All right, let's do one more of these. Find sine of 2u, where u is equal to this in quadrant 2. So once again, I'm in quadrant 2. So let's go ahead and draw this. And so cosine of u, so let's go ahead and let's put my u here. U, make this look like our u. Let's just mulligan that. So here's my u. I'm in quadrant 2. So here it'd be minus 2 and 5. And so the other one, we know what this is. If I have 5 and 2, just because we literally just did this on page 4, this is square root of 21. How do we get that? It was the hypotenuse squared minus 2 squared. That gives me 21. And since this is the opposite angle and quadrant 2, the y value will be positive. So sine of 2u How am I going to find that? Well, I'm just use my double angle formula. And my double angle formula here is 2 sine of u cosine u. And this one's actually easier than the other one, or not as easy as the first one, but easier than the tangent one. Will be 2 sine of u. What's sine of u? Well, that's square root 21 over 5. What is cosine of u? Well, that's right here, minus 2 square root 5. And so if I put this all together, I'll get minus 4 square root 21 over 25. All right, one last page, guys, and then we're done. So these are the product of sum formulas and sum to product formulas. I don't even think no, I think I gave you one of these. Oops. All right, so product to sum. So here if I have sine of u cosine b, I can rewrite this as 1 plus, or 1/2 of the quantity of u plus b plus sine of u minus sine of b, right? And so these are just products of our double angle or addition formulas. And you get a whole bunch of these: cosine u sine of b, cosine u cosine b, sine u sine b, and the whole list, right? The whole list. Anyway, any two ways you can multiply these together, you can get a thing. And then we can go from sum to product. So here I have a sum of two things. I can rewrite these as a product of two things. This is more something I want you to have seen, right? Something you've seen before. I'll have you work one or two problems. I don't think this will end up on the little exam. Wait, go back. Okay, wait, can you go back? Yes, go back. Let's go back. Page 5, right? Going back to page 5. Boop. This one? Okay, thank you. All right. Let's go back to page 6. All right, so let's just, I think I'll have one or two homework problems. I'm not real, pretty sure I can say this. It is unlikely that I'll put this on the test, and if I do, I'll let you know. But you will have to do a homework problem. I don't know, some of these could be easier than others. I know, I'm still gonna, let me finish writing the test today before I say what's on it, okay? Let me reserve the right to do that. All right, so I want to write this sum as a product. Well, how am I going to do that? Well, I'm going to use one of these. Which one of these am I going to use? Why, this one, right? So where u is going to be equal to 7x and b is going to be equal to 3x. And so here, I'm going to write this as a product. So it'd be 2 sine of 7x, or here, 7x plus 3x. So it'll be 7x plus 3x all over 2. And then we cosine of 7x minus 3x all over 2. And if I just simplify that out, I'll get 2. This becomes 10x. So sine of 10x divided by 2 would be 5x. This will be 4x divided by 2, so it'll be cosine of 2x. And so here I've taken a product, and I've taken a sum and written it as a product. And that's what that means. What are we going to use this for? We're going to use this to verify identities. So let's pretend I have this identity right here. And I want to say this is equal to tangent x. Well, which side's more awful? Well, this side's more awful, right? So we're going to start with the left-hand side. And we're actually going to write these as in order to kind of do anything, it's like, what can I do here? Well, nothing really. What can I do here? Nothing really. If I multiply stuff, I don't do anything. So the only thing I'm left with makes any sense to do is to either input my triple angle formulas, right? Which we calculated both the triple angle formula for sine and cosine in the notes, and then kind of crunch through the numbers. Or we could use these product sum things. So we just step out one way. And so we can use these and see if that doesn't simplify it. So let's try using these to simplify it. So let's do that. So here, I'm going to write, here I'm going to make this my u, this my v, and this will be my u and my v. We're going to do this twice. And so it'll be sine minus sine, right? So here we're going to be using this one, right? So on top, we're going to get 2 of our u. So this will be cosine of 2 plus b divided by 2. So it would be 3x plus x. So it would be 3x plus x divided by 2 times sine of 3x minus x divided by 2. And then for the bottom, here let's do the same thing. Here we'll have cosine of 3x plus an x. So this will be 2 cosine. Here we have cosine of 3x. So here we have cosine of 3x plus x divided by 2. And then here cosine again, cosine of 3x minus x divided by 2. If I crunch through this, I get 2 cosine. This is 4x divided by 2, so it would be 2x. Sine of 3x minus x will be 2x divided by 2 is just x, so sine of x. All over 2 cosine of 3x plus x divided by 2 is 2. It's cosine 2x. And this will be cosine of 3x minus x, which is 2x, divided by 2 is just cosine of x. Here I can cross off the 2's, I can cross off the 2 cosine of x. This is equal to tangent x, which is equal to my right-hand side. All right, we've hit the end of the fun.